Okay guys, so in this video what we're going to be talking about is binary ionic compounds. Now what a binary ionic compound is it's an ionic compound that contains only two, that's what bi means, two different types of ions. So for this video, make sure that you've got your periodic table that we did SPDF on, because the back has all of our ions, okay? So what we want to do, or what we want to find out, is how do we determine the formula or write the name for ionic compounds. Now, there are other types of ionic compounds that we'll talk about later. We'll talk about ionic compounds containing transition metals. We'll talk about ionic compounds that contain polyatomic ions. For now, we're going to start very basic and very simple. Now, when we talk about ionic compounds, there are some words that we've talked about before that we should still know. First word is, we need to know what an ion is. Okay? Really important. It's an ionic compound, so we need to know what an ion is. Ions were atoms that gain or lose electrons. Because they gain or lose electrons, they are no longer neutral. They have a charge. Okay? There were two types of ions we talked about. We talked about cations and we talked about anions. Cations have a positive charge. The reason that they are positive is they lost electrons. Remember, electrons have a negative charge. We have less of them, so we're positive. The important thing that we need to know about cations in this as well is our cations are always going to be metals. So our metals are going to lose electrons. They're going to form a positive charge. Anions are negative. Cations are positive. Anions are negative. Cations lose electrons. Anions gain electrons. Cations are metals. Anions are nonmetals. So when we create an ionic compound, what we're going to do is we are going to have a metal, and that metal is going to have a positive charge. We're going to combine it with a nonmetal, and that nonmetal is going to have a negative charge, and when we put them together, the charges are going to cancel out. It's very important that our net charges cancel out. So here's the way we determine the formula for ionic charges, or ionic compounds. Let's say I'm putting together a compound of calcium and how about oxygen? Okay. I'm going to look at my periodic table. I'm going to find calcium. Calcium has a +2 charge. So I write it as Ca +2. Oxygen has a charge of -2. When the charges have the same number but different values, positive and negative, they cancel out and they'll be neutral. So all I have to do is when the numbers are the same, I squish those two ions together and just write it as CaO. Now when I name this, I name the cation first. I always write the cation first, the positive first. I write it first in the formula. Positive always comes first. So I name my cation first. Ca is calcium. That didn't change. However, in a compound, my negative ion, I change the ending. If you look at your periodic table with charges, it doesn't say oxygen, it says oxide. I changed that ending to IDE. So instead of calcium oxygen, my compound is calcium oxide. Okay? So when charges are the same, all I do is I squish them together. What if charges are different? Let's say instead of, that one's a little hard to read, instead of calcium and oxygen, let's say I add calcium and fluorine. Okay? Well, calcium is still a +2. This time, fluorine, if I look at my periodic table, has a charge of -1. I always have to have a positive and a negative, and my charges should cancel out, but right now they don't. So when my charges don't match up, here's what I do. I'm going to take the number from the negative and move it over here and say I need 1 calcium. I'm going to take the number from the positive and move it over here and say I need 2 fluorines. And the way I'm working this out, 1 times 2 positive would be a +2. 2 times -1 would be a -2, and now my charges will cancel out. Even though I wrote the numbers in front of the elements on this side, when I write the formula, I would say that I have Ca1. I can either write the 1 or leave it off. And then I've got 2 Fs. So I flip-flop the charges. 2, I only need 1. 1, I'm going to need 2. So it would look like this. Now, even though I have 2 Fs, when I name it the exact same way I did before. I name my cation first, and it stays the same. I name my anion second. Fluorine becomes fluoride. So again, if the charges don't match, I need to flip them. So let's look at calcium again. But this time, let's partner him with nitrogen. Calcium's still always a +2. This time, nitrogen is a -3. Okay? So I have a plus and a minus, but the numbers don't match. So when the numbers don't match, I flip them. This 3 is going to go in front of calcium. This 2 is going to go in front of nitrogen. So I just bring these over. And the reason I'm bringing them over, 3 times 2 is +6. 2 times -3 is -6, and so the charges will cancel out again. So my formula would be Ca, and I need 3 of them, N, and I need 2 of them, And when I write the name, I name Ca, my cation, first. The name stays exactly the same as the element. I name my anion second. In this case, nitrogen becomes nitride. So my compound is calcium nitride. Easy enough? We'll practice this again more in class, so don't panic. I know we went kind of fast.